Good morning, class. This is your day 5 of week 5, and here's your video in case you need help with those problems. This is day 5. The learning goal for today says find common units and number of units to compare two fractions. So we're still comparing fractions, and I notice here that we're going to be using area models to find the same denominator. That's what it means when it says common units. We're finding the same fractions with the same denominator or numerator, the number of units. Okay, so number 1 says draw an area model for each pair of fractions and use it to compare the two fractions by writing greater than, less than, or equal to on the line. The first two have been partially done for you. And then it says here that each rectangle represents one whole. Okay, so I am going to go on to 1B, okay? The example here shows a few extra steps that I don't want you guys to do that. I mean, it's okay if you do them, but I am not requiring you to do those extra steps. I am going to show it the way that we would do it in class, okay? So I know that I need to compare 2/3 and 3/4. And then right away we need to notice that 3 and 4 are not the same denominator. So then we need to create new fractions that have the same denominator. And that way we can compare. So I am going to go ahead and prepare the space here. Okay, and this is where I am going to put the new fractions that I will make. So I am going to use these two models here on the right side. So the first one, it seems to me that the first one is going to be to represent the first fraction, 2/3, because I noticed 1, 2, 3 units inside of the one whole. And so let me go ahead and shade in 1, 2 units, okay? And so here's 2/3, and then the second one has 1, 2, 3, 4. Well, that must be for the second fraction. So I am going to put 3/4 here on the side and shading 3 of them because I'm representing 3/4. So there's 3/4. Now, yesterday, if you joined Zoom, we were reviewing how if we want to create new fractions with the same denominator, we multiply each fraction, as in 2/3 and 3/4, we multiply each one by the opposite denominator. For example, we would go 2/3 times, and the opposite denominator would be 4, so times 4, top and bottom. And then 3/4, that one would be 3/4 times the opposite denominator is 3. So times 3, top and bottom. And if I do that, I get 3 times 3 is 9, and 4 times 3 is 12. And then the first one, let's multiply it. 2 times 4 is 8, and 3 times 4 is 12. So there you have it. This is what we want to have. We want to have the same denominator on both fractions so that then we can compare. So it seems like 2/3 is going to be 8/12, okay? And it looks like 3/4 is 9/12. Now we can already go ahead and compare, okay? 8/12 compared to 9/12. 8 is less than 9, so 2/3 should be less than 3/4. But then they're asking us to show how this multiplying top and bottom works with pictures. If you notice on the first one here, we multiplied by 4 top and bottom, right? So we made 4 times as many units, shaded and unshaded. If you remember in class, we would show that by decomposing by the number of units in the second model. For example, in the second model, we have 1, 2, 3, 4 rows. And so if I transfer those to decompose here, 1, 2, 3, so there I have 1, 2, 3, 4 rows. If I do that, I just decomposed by the number of units in the second model. If I do that, watch what happens. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Or 3 times 4 is 12, which is what I got here. Okay, my new denominator here. And then shaded, I have 1, 2, 3, 4, 5, 6, 7, 8. So that'll be my 8 units here. And so this is, the model is just to show how the multiplying top and bottom works. Now, in the second model, let me get rid of this. In the second model, what we did is we went ahead and multiplied by 3, the opposite denominator. Well, that would be like decomposing by the number of units on top on the first model. On the first model, we had 1, 2, 3 columns. If I do that, 1, 2, and then I have 1, 2, 3 columns, what I just did is I decomposed into the number of units in the opposite model or the first model. And if I do that, I have 1, 2, 3, and then 1, 2, 3, 4. 3 times 4 is 12, right? And then shaded of those 12s, I have 1, 2, 3, 1, 2, 3. 3 times 3 is 9. I have 9 12s, which is the new fraction that we just made. Okay, so when you do your work today, the one thing that I want you to do is I want you to decompose. First of all, represent the two fractions that you are comparing, and then go ahead and decompose by drawing either vertical or horizontal lines to decompose into the number of units that the opposite model has, okay? And then you can go ahead and multiply top and bottom, and you already know it's going to be by the opposite denominator. Label here the new fractions that you are making, and then compare and put your symbol in there. And that's it. That would be it for number 1. Again, these steps right here, they did a few extra steps. They still end up with the same answers, but it's okay if you only do the way that I just showed you. Okay? So that's number 1. Number 2 says rename the fractions as needed using multiplication in order to compare. Okay, each pair of fractions by writing greater than, less than, or equal to. Rename the fractions as needed. So if you notice here, it doesn't tell us to use area models. Right here it said to draw. Number 2 doesn't say to draw any models. You may draw models if that's what works for you, if it helps you, but if not, you can simply do what we did in class, which was preparing the space here, and then bringing this one down here, 2/3, and then this one down here, 2/4, and then multiplying each one by the opposite denominator. Well, 2/3, the opposite denominator of 2/3 is 4. So I'm going to multiply 2/3 by 4/4 here, 4 by 4 top and bottom. And then the opposite denominator of 2/4 is 3. So then I will multiply 2/4 by 3, top and bottom. And then when I do that, I make new fractions, okay? And I'm gonna put them up here right below the original fractions. So I know that 2 times 4 is 8, and then 3 times 4 is 12. And then this one, 2 times 3 is 6, and 4 times 3 is 12. So 6, 12. So now that we have 12 and 12 as denominators, we can go ahead and accurately compare. 8 12 is more than 6 12. So then the symbol is greater than. And so that's how you would do number 2. Again, if it helps you to draw models, by all means, go ahead and use them. But if not, you can just multiply top and bottom, okay, by the opposite denominator. And then here, number 3 says to use any method to compare the fractions. And then you need to record or write your answer using the symbols. Again, any method, either area model or multiplying top and bottom, okay? There's a word problem here. It says explain which method you prefer. using to compare fractions. Explain which method you prefer using to compare fractions. Provide an example using words, pictures, or numbers. So this is going to be, everybody's going to answer differently because everybody prefers different methods. So you're going to say, I prefer to use multiplication to create new fractions with the same denominator, or I prefer to use area models. Whichever method that you prefer, you explain it in here. And then don't forget to write your example, okay? So for the example, you could write a pair of fractions like these, and then you can show how you compared it with multiplication top and bottom, or if you said that you prefer to use area models, then you can draw your models, okay? And then solve the example that you're going to provide. Lastly, we have an application problem. It says, Janet uses 4 feet of ribbon to decorate each pillow. The ribbon comes in 225 foot rolls. How many pillows will she be able to decorate with 1 roll of ribbon? Will there be any ribbon left? Okay, so it sounds to me left. In math, one of the 4 operations that we do are addition, subtraction, multiplication, and division. And it sounds to me when we have left, it's either subtraction or a remainder, as in division. So I am going to go ahead and let you figure out this word problem. Okay, decide which operation you would be doing. Don't forget to write an answer statement for the question and then solve. And that's it for this week. Have a wonderful weekend, and I will see you next week, boys and girls.